When you go online, you're being tracked. That's no secret. For many years, third-party cookies were a popular way advertisers traced users across independent websites in order to build a unique profile to target for advertising. Everywhere you visited may have left a little breadcrumb for the other sites to see. But the browser world is changing, and almost all of the popular browsers have switched over and started rejecting third-party cookies. Interestingly, Chrome has not yet done that, as we'll discuss further today. Does this mean advertisers have just given up on tracking? Of course not. Today we explore how tracking now functions in a first-party cookie world.
My name is Shaur Munir. I'm currently a PhD student at University of California, Davis. I'm working with Professor Zubair Shafiq, and my research is mostly around development and then evaluation of privacy-preserving technologies and how they affect users' online experiences.
Could you give a rough, high-level, or maybe as detailed as you want to go, what is a privacy-preserving technology?
A privacy-preserving technology is mostly to ensure that users' online activity is shielded from parties and other actors with whom they do not want to share their information with. So it's more about giving users the control over what information is shared about them and how that information is being used. So if there's any third parties, any other parties which may use that information to track users' activities for no purpose at all, or for the purposes of showing them specific kind of advertisements or tracking their behavior, these privacy-preserving technologies tend to give that control back to the user.
And where are we at in terms of adoption? Do consumers generally have all the tools they should have, or are we making progress towards that?
It's an ever evolving field, so there's always that cat and mouse game between the privacy preserving technologies and then the advertisers and trackers who want to make use of users' personal data. We don't really have any statistics at the moment, but I can say that there is a lot more awareness now than it was a few years ago. With the new laws that have been passed in European Union and then also in California. So there is some discussion around that, and then users are more generally aware of their privacy these days, and they are looking for new ways to adopt these privacy preserving technologies than ever before.
No, I think it's good that as a society and different places are doing different things, we're all having serious discussions about the use of personal data. But taking a step back and looking at it from the advertiser's point of view, what do they want with our personal data? What's the best case, worst case?
So the best case, if you look at from the advertiser's point of view, they will give reasons like the user wants to see ads which are relevant to their taste.
Yeah.
So for example, a person living in America would not really want to see advertisements which do not really concern their own geographical location or their own use cases. So they wouldn't want to see any new product which is launching only in UK. They would want to see products which are launching in US around their own area. And they also want to make use of this personal data to make sure that the user is able to see a vast variety of different ads. So ad retargeting is one of the very valid use cases that they talk about, where a user is not bombarded with the same kind of ads every time they go online. So the ads have to be varied, the ads have to be different each time, and ads also have to be relevant to the user itself too.
Yeah, the ads following us around has been quite a punching bag on this season. A lot of people have a dislike for that, myself included. How do they accomplish that? What is the mechanism of the tracking?
So the basic mechanism of tracking is to identify a user. So to know if to know what kind of ad to show a user, you first have to know which user it is. And once you know which user it is, and not only on one single site, but you want to know the user on multiple different devices and multiple different browsers, multiple different sites, because the web is very diverse today. You can browse on your mobile, you can browse on your TV, you can browse on your laptops. Identifying that same user across all of these different devices and then seeing what kind of applications they are using, what kind of sites they are visiting, and what kinds of products that they are searching for on Amazon or on eBay. So this information is very critical for advertisements to be relevant to the user. The fundamental piece in all of this is identifying who the user actually is, because it's on all these different devices. All of these different devices have all of these different security policies and privacy policies. So navigating all of those and then combining those together and navigating all of those policies to identify the user is what is at the core of this whole ecosystem.
So if I wanted to take a naive approach, I might say an identity of a user is an IP address plus the user agent string that their browser is sending. And that's, not necessarily unique, but fairly unique. I could track someone anonymously as that identifier. Is that what's going on, or is there something more sophisticated?
In some cases that might be unique, but there are multiple cases where the IP addresses are either changed daily by the ISP themselves, or they might be shared across a lot of different users which have a lot of different tastes. So it is one indicator of a returning user, but it's not always the case that an IP address plus the user agent that they are using would be unique enough for the advertisements to be relevant to them.
So what sort of tool or software system do I use to go beyond those and have a bit more of a memory of a person?
So previously it was very simple for advertisers and trackers. What they used to do was once you visited a website, there were third-party scripts present, there were third-party videos embedded, there were third-party different resources on that website, which could set cookies, and on those cookies they would set an identifier of the user. And once the user moved away from that site and went to another site where that third party was also present, they would simply get that identifier back and then link those two sites together. So they would know that the user first visited Amazon.com and searched something on it. And then they visited another sports-based Nike, for example. And they would correlate both of these together using that third-party identifier. Now, the problem for advertisers now is that third-party cookies are going away. Safari has already blocked third-party cookies. Firefox has already blocked third-party cookies, mostly blocked third-party cookies, and Google Chrome is dragging feet a little bit, but it is expected that by 2024, the late 2024, Google Chrome will also be blocking third-party cookies. So once these third-party cookies are blocked, then it becomes difficult, or it becomes a little bit more challenging for these advertisers and trackers to know what's going on when a user visits multiple different sites. And so then they rely on some different kind of information together. And that different information is a combination of the users' IP addresses, users' email addresses, users' any other information that user can provide on a site. They take that and combine that and then use that to identify if it's the same returning user or not. So for example, if you go on Nike.com and the Nike asks you to enter your email address, you enter that email address and that email address is sent to a third-party advertiser by the different collaborations that Nike has with those advertisers. And then you go on another site, and that another site also asks for your email address. And that email address is also then again sent to that same third party. So that's how they try to correlate these two together these days.
Well, third-party cookies have certainly been used for this sort of tracking. That's maybe their most prominent use case. I'm not sure. I guess I'm just curious, do you know, are there any innocent victims of this move away from third-party cookies? Are there any legitimate systems that consumers enjoy today that they won't be able to enjoy as that change rolls out?
There are certain use cases which Google Chrome also says that third-party cookies are used for. One of the use cases that we can talk about is integration of different chats on different sites. So there are third-party services that provide chat functionality, and that chat functionality relies on third-party cookies. So for example, if there's a Facebook chat on a different website where you can talk to the first party's Facebook Messenger account, then that requires third-party login, and that third-party login is served through a third-party cookie. So that's maintained through a third-party cookie. And there are other use cases where single sign-ons are sometimes supported by third-party cookies. And there are some use cases, but most of the use cases are currently now moving towards first-party cookie anyway. But there are some small varied use cases that Google Chrome and other supporters of third-party cookie use to justify their presence.
So if the switch was just, unilaterally enforced starting tomorrow, how much of the internet would break?
From our analysis, I believe it will not break to the extent that people expect now. Although Google Chrome is a pretty popular browser, it's around 60 to 70% of the market share is dominated by Google Chrome, but there is still a significant number of users both on Safari and Firefox, and they have been surviving without third-party cookies for a number of years now. The most breakage that you will see will be on the side of advertisements and trackers. So their business will be impacted the most, which is what Google is trying to avoid by their different new APIs through Topics API and their recent Origin trials, which involve Flock and then Fledge. Mostly the impact you will see is on some of the revenue by advertisers.
As you'd hinted at a little bit earlier, if we're moving in this direction, advertisers are thinking ahead, they still want to do tracking, they're going to have to take some action. What sort of migration will take place there?
That migration actually we discovered that has been taking place for quite some time now, because it's no surprise that this is a $1 billion industry, and when there are billions of dollars at stake, then they try to stay ahead of the game. So when they realize that third-party cookies are going to be blocked eventually, they will not wait for third-party cookies to be blocked. They will preempt that action and then try to take some countermeasures that can help them stay ahead of the game. One of the things that they are moving towards is collaborating with first parties. The first-party data is something that users cannot avoid giving. So the site that you're visiting, if the site that you're visiting asks for any information about you, you're most likely to provide that information. And once that first party has that information, they can also share it with third parties. And combining that data across different sites, that's one way of them to create sort of a user profile across different sites, which we have also observed during our analysis and research.
Today's data lives in the cloud, so your business needs a cloud-native, next-generation solution for intelligent, accessible data analytics. Astrato is a modern BI solution for modern BI teams. Your organization's data already lives in the cloud, which means you can access the single source of truth. Astrato accesses your data where it already lives with a live query approach, so there's no need for data movement, ever. You maintain the agility, speed, and elasticity that modern cloud data warehouses deliver. Astrato's gallery of examples will give you a quick impression of the power Astrato can give your team. The sales workbook example gives me a good indication of the quality of dashboard I can create for my collaborators. And the Tour de France workshop shows off a few other features on competitive cycling data that I could see being really inspiring on implementation for when I have a demanding executive that needs to really slice and dice the data in a lot of custom ways. When I first started exploring Astrato, I connected a Google Sheet of one of my datasets just so I could kick the tires. After that, integrating with Snowflake as a backend was super easy. You'll find that integration to be pretty painless and definitely worth your time checking out if you're a Snowflake user. With Astrato, you can bring complex data to life with no coding skills necessary. To learn more, visit astrato.io/dataskeptic. Astrato is ASTRATO. Astrato.io/dataskeptic. Thanks to our sponsor, BBEdit. If you're a Mac user and you have any need whatsoever for a text editor, which, let's face it, that's got to be all of us, you have got to check out BBEdit. BBEdit 14 provides Mac users the most powerful, professional-grade text editor around. It's known as capable and rock-solid, and can process files that are large enough to bring other editors to their knees. This tool's been beloved for over 25 years, and I can understand why. If I'm just typing up some simple hello world, I guess any text editor will do. But when I really get into the weeds and need to do some data processing, maybe I've got a big messy file, I need to find all the non-ASCII characters and remove them, BBEdit's there for me. It has best-of-breed multi-file search and replace and great scripting support for text transformations. There's a whole menu of text transformations that you'll find handy. If you're a serious data scientist or software engineer, you're going to bump into situations where you need a powerful text editor. So download and try BBEdit today. You can get it at www.barebones.com. See how much your productivity can increase. barebones.com and download BBEdit. So then as there's a migration to maybe doing things more first-party cookie. As you kind of hinted at, sites could be colluding behind the scenes. I could have some server-side integration with a tracking platform and somehow utilize my first-party cookie as part of that network. How can we measure that? It seems to be kind of behind a black box.
The way that it's implemented right now is that there is less collusion at server side and more collusion on the front end. So what it means is that most of the first party sites, they don't really want to burden themselves with the whole collection of data, with the whole integration of first party cookies and the sharing of data with different third parties. So what they do is that they integrate these services which claim to be identity providers in the first party context. They integrate themselves in the website, then they agree on a data model. It allows these first parties to share a data in a structured format with the third party. And then the third party sends the data to their own servers. And from that server, all the calculation is done, all the graphs are made, the connected identity graphs are made. And then a final identifier of that user is sent back to the website or the web browser that user is currently on. And then it's set in a first party cookie, and that first party cookie is then shared along with multiple different third parties. So that whole interaction that we see, fortunately, we have been able to map it out, and we have been able to see that happening in real time. So for now, there is less involvement on server side and more involvement on the front end where we can actually see this happening.
Could we zoom in on that graph? The computer scientist in me wants to know about what the edges and nodes are.
That graph basically is a representation of all the information about the user that they have. So think of that graph as a sort of an activity of a user across all different sites. So each node will be one site where the user performs some activity and all the information that the party is able to collect from that site. So let's say on site 1, they are able to collect an email address, some IP addresses, some user identifiers that are set by the first party, and that will become the node on that first site. Then the user moves on to another site. And on that site, they also collect some email addresses, but they collect some other information which is not the same as this first site, but that email address is the same across those two different nodes. So using that email address, which is common on both of those nodes, they can create an edge which represents that it's the same user which visited site 1 and site 2. And because that edge is now created and that graph is now connected, they can assign the same identifier to both of those edges and both of those users which visited those nodes. And that is essentially how an identity graph is currently being made with all of that information about that user.
And to be clear, is that the identity graph something an advertising network would want to create so they have a profile of a user?
Yeah, essentially, yes. But we have seen in our analysis and our research on some of these existing services that we are currently seeing a split in the industry. Previously, there was an advertising company which would profile the user and keep track of user activity. But because this identity thing is now becoming so specialized that it needs a special form of data collection and special form of computation at the back end, we have seen that advertising companies and identity resolution companies are kind of splitting apart. So there is an example of a new company, ID5, which is only specializing in creating or resolving users' identity on different websites. So they don't participate in any of the ad exchanges. They don't participate as a DSP or RSSP or any of those middle parties. They only provide users' identity on different sites. Their only specialization is collecting users' data and resolving that data across different sites to return a single user identifier. And that identifier is then used by advertisers to determine if it's the same user or not. So they have different partners across these different sites.
And that identifier, I think the primary goal is a unique ID, which could just be, a random UUID for all my algorithm cares, right? I just want to know that X and Y are the same identity. Is there more to it? If I were to get a hold of one of those records, would it know my birthday and my parrot's name and that sort of thing?
It's certainly definitely possible that the information that they collect on different sites is your birthday too. But that information is with ID5, and only thing that they will provide the publisher and other advertisers is the final identifier that they have. So it's definitely very certainly possible that they collect this information and they use that information to create those edges that we talked about earlier.
And in terms of the user activity, At the most rudimentary level, that's like the mouse movements and the clicks, but I don't know if that click stream is super useful. You probably want something a little bit more abstract. Do you know what a user activity event or annotation looks like?
On a single site.
Yeah, what is that? If you said, here's some user activity data, what is it? What's the schema, maybe?
That user activity can include the actions there. So remember that we talked about a data model first. So that data model also agrees upon some of the behaviors that the user might have on a site. So when you're talking about first party, then there's a lot of activity which can only be captured by a first party, and that behavior is something that which is far off from just a simple mouse click or mouse scrolling or something. For example, if you go on a site and you or watch a particular video, and the first party identifies that as some sort of a behavior which they have agreed upon with that identity resolution service. So that behavior is basically what will be conveyed to that identity resolution service, and they can use that behavior as sort of a fingerprint of the user. So this is going a little bit further than just looking at the user activity at a browser or a mouse level.
And you've mentioned a few observations that came out of this work, a few of the insights. I haven't yet asked you about the raw data. Can we talk a little bit about the crawling process and what you got up to there?
What we did was that we performed this analysis on 10,000 top websites. We used two different crawls here. In one of the crawls we allowed third-party cookies to be set, and in the other crawl we blocked third-party cookies. Our intuition behind doing this was that if there are some advertisers and trackers who are currently in the process of shifting from first party to third party to first party cookies, then it would mean that blocking third party cookies would prompt them to use first party cookies. So we wanted to compare how their behavior changes when we block third party cookies. So we did two separate crawls at the same time we did two separate crawls for these 10,000 different sites, and then we looked at how the number of cookies and number of requests and number of responses change across these two different crawls. And from those differences, we observed that there were some actors which were proactively changing from third party to first party cookies, and that was kind of interesting for us, because when we further analyzed what their documentation said and what their own website said and what their interaction basically said, we realized that these advertisers and trackers were currently in the process of adopting to first party cookies, and that led us to discovering some of the behaviors and some of the interactions that are fundamental to this first party based tracking.
I know a big piece of the work is machine learning. Where does the ML problem come into this?
So once we realized that there are certain parties or certain advertisers which are proactively shifting from third party to first party, then we were able to analyze their behavior and see what kind of interactions that they perform with the website and with different other actors present on the website. And then we realized that this behavior might be similar enough across different advertisers and trackers to allow us to create an algorithm, a machine learning algorithm, which will detect all of the advertisers and trackers which are using these first party cookies for tracking purposes. So we collected all of these features which indicate whether a first party cookie is being set by multiple different actors or not. Is it being sent to multiple different actors through HTTP requests? Is it being set by a script which is sending a lot of different requests to a lot of different endpoints or not? So all of these different features, we use those features, and then we trained a ML classifier, a random forest classifier, to automatically detect those first party cookies as either tracking or functional, which allowed us to create some sort of a list which we can use to block these first party cookies.
So that classifier had to be trained on some ground truth data in the initial training
Yes.
phase. Where do you get that from?
That was kind of a challenging part because there's not a lot of information out there right now about which cookies are actually tracking and which cookies are actually functional. And the best information that we could have gotten was thanks to GDPR and CCPA. So they require the website to disclose all of the cookies which might be tracking or which might be functional. But the problem that we faced here was that we were not really sure that we can trust what a website is declaring, because we had found some existing work which said that there were some missing pieces in that information that they disclosed. So ultimately what we decided was to use a two-pronged approach here. We took all of the labels that all of the information that we can get from these pop-ups where they say that this cookie is tracking, because we theorized that a website itself wouldn't say that a cookie is tracking unless it really is tracking. So they might say that a cookie is not used for tracking if it was used for tracking, but it will never say that it's for tracking if it's for a functional purpose. So essentially we took all the tracking labels from that pop-up that you see when you visit a website, which is following these GDPR and other CCPA regulations. And then we also wanted to get the functional labels, that which cookies are actually used for functional purposes. So for that we made use of some of the filter lists which are currently being used for blocking tracking resources. So our hypothesis there was that if a cookie is being set by a script which is not labeled as tracking in any of the known filter lists, then there's a very good chance that the cookie set might also not be tracking in general. So we combined those two labels, and we got ourselves a fair enough ground truth for our classifier to train on.
And when you look at the performance metrics, I don't know if it's F1 score or accuracy or what you value, but how good of a job does this end up doing?
This actually ended up doing quite a good job. So we describe in our analysis that we classify cookies with a 91.06% accuracy. And we also compare it across some of the existing ways to classify cookies. It outperforms those by at least 10 to 12%.
Well, yeah, could you expand upon that? How did the baseline do it? And what explains the lift you achieved?
So the baseline that we used was another tool, Cookie Block, which also relies on some of these pop-ups that you see on these different websites. And their main use was relying on cookie names and some of the interactions some of the values that changes across different visits of a user for a cookie. So they posted an accuracy of around 80%, and we were able to outperform that by around 91%. But their approach is not really specific for first-party cookies. It was for both first-party and third-party cookies, which are declared by the website itself as either tracking or functional.
So if I understand correctly, provided the sites disclose the tracking cookies they have, that makes them compliant with CCPA. Is that correct?
GDPR requires that. I'll have to check if CCPA also requires them to show that dialog or not, but GDPR definitely does ask them to disclose all of the cookies and the purpose of the cookie that they have, and they also need to ask the user if they want to allow tracking cookies or not.
Yeah, so they need to follow all the rules, get their ducks in a row, but at the end of the day, this behavior is an allowed behavior. They can track this way.
Yes.
In terms of the model you've built now, pretty good accuracy and ability to find which cookies have this tracking in them. What decision do you want to inform with that signal?
We want to inform that which cookies in a first-party context are being used for tracking or not. And when we have that decision, then we can either choose to allow those first-party cookies or we can choose to delete them. And we tested it with an extension which takes all of those decisions and then deletes those first-party cookies. And then we wanted to see if deleting those first-party cookies would result in any breakage or not, so that the user functionality does not really get impacted when we start blocking first-party cookies, because you can block third-party cookies, but first-party cookies are generally used for functional purposes because they are set by the first party. So there's a logical reasoning to be made that blocking first-party cookies or interrupting any sort of first-party cookie setting would cause much more breakage than third-party cookies. So we wanted to test that too. So we made an extension which took that signals or decisions that the classifier makes and then see what sort of breakage do we see.
And can you give some high-level insights from that? Is it a lot? Is there a percentage? How much breakage, I guess?
We quantified that breakage using two different methods. We divided into 4 different functionalities that can exist on a site, which can be appearance of the website, which can be SSO logins, the third-party logins that a number of websites use. Then there are some additional functionalities like carts and some other useful functionalities that the sites provide. And then the navigation part, that moving from one page to another, that might get interrupted too. So we looked at breakage across all of these different 4 functionalities, and we also measured that whether there was a major breakage which would cause the functionality to cease existing on the site, or there was a minor breakage where there might be some issues with the functionality, but the user might still be able to make use of that functionality. And we found out that our approach resulted in a very small minor breakage on some of the navigation parts, but there was no other major or minor breakage across all of those 4 different functionalities. And when we compare this with the cookie block approach, which causes breakage on around 10% of the sites that we tested, and then there was another approach that we tested against, which was basically blocking all of the scripts which were labeled as tracking by some of the filter list or a web graph classifier which we compared against. That also resulted in 10% breakage, breaking on 10% of the sites. We basically proved that you can actually look at the first party tracking cookies, you can isolate them and you can block them, and it would not result in any sort of major breakage which might impact how user is using a website.
So it sounds like that might be part of whatever the next generation of privacy tools are. How far away do you think we are from this being a thing the average person who's very privacy conscious could have in their browser?
We think that we are at this point currently. So we found that a lot of the major advertisers and trackers have already moved on to using first-party cookies. And there were some which were already using third-party cookies and moved to first-party cookies once we blocked third-party cookies, but a major number of around 70% of them already use these first-party cookies for tracking. So if any user who is privacy conscious and wants to make sure that their activity is not really tracked and they don't want to get bombarded by these targeted advertisements, they really need to start looking at these first-party cookies too.
Do you have a vision for what a middle ground might look like? I mean, I want to have some amount of privacy, but I don't want to see generic ads. Like, I have no children. Never show me things about babies. I don't want it. And I wouldn't mind ads about parrot toys because we do have a parrot. So there's certain things I wouldn't mind revealing about myself, but certainly not everything. What would the future look like if you had a lot of influence on it?
I think the advertising companies and some of the browsers really need to sit down and decide upon a protocol which allows anonymity, but also allows some of the information to be used about the user, but that information should be generic enough so that it does not really pinpoint the user's own behaviors and activity, but it should be generic enough, or it should be targeted enough that some of the behavior, some of the interests that user has can be shared with these advertisers. One of the things that Google was trying to do with FLoC, although it had some of its downsides too, and it could be used in combination with some other techniques to pinpoint a user's activity, it was at least a step in the right direction, that there should not be a single user which is targeted, but a group of users which has the same sort of interest. So let's say that you don't want to get bombarded by advertisement related to children. So then you will be grouped alongside a large number of people who don't want to see that advertisements. And the advertisers can target all of that group at the same time and not the individual users. So that's something I think we need to move towards and make sure that privacy is built into these browsers and these different tools by design, and not something which these companies can really target and look at individual different users.
What's next for you?
So what's next for us is that we are also now looking into some of the other things that this third-party cookie blockage might have impact on. So one thing that we are currently looking into is how fraud detection, which is a very valid use case of some of these third-party cookies and some of those also first-party cookies, how does that get impacted if we use these privacy-preserving tools? So some of the valid use cases might be impacted, and then we'll need to adopt ourselves and our tools to make sure that fraud detection and other malicious behaviors also get protected. but the privacy of the user still remains intact. So that's something that we are working on. And then we're also working on looking at other ways where not only first-party cookies, but other storage mechanisms and other sharing mechanisms on the web browser itself are being used for tracking now that third-party cookies are blocked.
And is there anywhere listeners can follow you online?
Yeah, I'm on Twitter. I'm on most of the other social medias, and you can also follow my GitHub page to see any updates that I might post.
We'll have links to all that in the show notes.
Thank you for having me. It was a great talk.
Our season on ad tech seems quite inseparable from topics of privacy and tracking. This isn't the first, nor will it be the last installment that explores some angle on this topic.
So Alphabet gets to see all of the browsing history. The advertisers get to put ads in front of us. We create the identical browsing profile. This time we make sure to block access to all of Alphabet's trackers. And then we compare statistically the ads we got from the first experiment. And it turns out if there is a statistically significant difference between these two, it must be because Alphabet was sharing data with these advertisers.
That's next week on Data Skeptic Ad Tech.